In this lesson, we're going to talk about Chapter 23, Angle Properties. First, angle facts. Here are some angle facts. Angles on a straight line add up to 180 degrees. The sum of angles at a point is 360 degrees. And opposite angles are equal, like in this picture, A is equal to C and B is equal to D. Sometimes opposite angles are called vertically opposite angles. Next, parallel lines. So, arrowhead indicate parallel lines. The line that crosses the parallel lines is a transversal. Angles like these are corresponding angles. These are alternate angles. And these are called allied angles or interior angles.
Try 3.3 Angles in a triangle. Three angles in any triangle are add up to 180 degrees. So A plus B plus C is equal to 180 degrees. You can prove this by drawing a line through C parallel to AB. A equal to D, B equal to E. They are alternate angles. D plus E plus C is equal to 180 degrees because they are on a straight line. So A plus B plus C is equal to 180 degrees. We have some special triangles. First, the equilateral triangle. All sides are equal and all interior angles are 60 degrees. Isosceles triangle. Two sides are equal, so two equal interior angles are at the foot of two equal sides. Right angle triangle has an interior angle of 90 degrees, so A plus B is equal to 90 degrees. Try 3.4 Angles in a quadrilateral. The four angles in any quadrilateral are added to 360 degrees. So A plus B plus C plus D is equal to 360 degrees. You can check this by dividing the quadrilateral into two triangles, because the angles in the triangle are add up to 180 degrees. So two triangles is 360 degrees. We have some special quadrilateral. First, the parallelogram. Opposite sides are equal and parallel to each other. Diagonals bisect each other and opposite angles are equal. Rhombus is a parallelogram but all sides are equal. Diagonals bisect each other at right angles and they bisect the angles at the vertex. Kite. Two pairs of equal adjacent sides and diagonals bisect at right angles. The opposite angles between the sides of different length are equal. Trapezium. Two parallel sides and the sum of interior angles at the end of each non-parallel side is 180 degrees. So A plus D is equal to B plus C.
The next part is about polygons. Firstly, regular polygons. So there are multiple types of regular polygons like square, pentagon, hexagon. A polygon is regular if all its interior angles are equal and all its sides are the same length. This is a picture of the most common regular polygons. Angles in a regular polygon. If a regular polygon has n sides, each exterior angle is 360 degrees divided by n. To find the interior angle, just subtract the value of the exterior angle from 180 degrees. Secondly, irregular polygons. So any polygon that doesn't have sides with the same length and angles with the same size are irregular. The exterior angles of any polygon add up to 360 degrees. So how do we find angles in a polygon? Divide the polygon into several triangles to find out the sum of the interior angles. This is a picture showing that. From the picture, you can see that for an n-sided polygon, the sum of the interior angles S is given by the formula S equals 180 times n minus 2 degrees. The exterior angle is 180 degrees minus the adjacent interior angle.
Next, we have tangents and diameters. What is a tangent? Tangent, which is called tiếp tuyến in Vietnamese, it's a straight line that touches a circle at a certain point. It's only one point. That point is called the point of contact, tiếp điểm. We have examples right here. LP, it's a tangent, and P, it's a point of contact. Here's another examples. You can already tell that PT, it's a tangent, and PS is also a tangent. And T and S are the point of contact. Okay, so come back for a bit. What do you notice at T and S? Yes, a tangent of a circle is perpendicular to the radius drawn to the point of contact. OA, OB are two radius of the circle. The radius OA, it's perpendicular to the tangent AC, and the radius OB, it's perpendicular to the tangent BC. AB, it's a diameter that divides the circle into two semicircles. Every angle at the circumference of a semicircle that is subtended by the diameter of the semicircle, it's a right angle. So we have APB, it's a right angle subtended by the diameter AB. Next, I have some more examples. So angle ACB, it's also a right angle because it is also subtended by the diameter. Here we have an example from the book. It's really easy. The next one is angles in a circle. Here we give you two more useful theorems by doing circles. If you draw lines from each end of an arc to the center of a circle, they form an angle at the center. The arc has subtended an angle at the center. That angle is called góc ở tâm. The angle at the center, góc ở tâm of a circle, it's twice the angle at the circumference, góc nội tiếp, that is subtended by the same arc. For you guys to easily understand this, we have a picture of a circle right here, and you can see AOB, it's the angle at the center of the circle, and APB, it's the angle at the circumference, and angle AOB, it's equal to twice angle APB. This is the second theorem. Angles subtended at the same circumference, góc nội tiếp, and the same segments of a circle are equal. Points B and D on the circumference are both subtended by the same arc AB. So that angle BPA, it's equal to angle ADB. That translates to Vietnamese as hai góc nội tiếp cùng chắn một cung thì bằng nhau. Okay, so this is the first example. It's that we gave you a circle that have some angles, and we give you a size of angles, and you have to find the unknown. So this is the way to do it. It's pretty simple, but if you have any problem, please tell us right now so that we can solve it. And here's another kind of example. Still find the unknown angle, but we have some other type of examples.
The next part is about cyclic quadrilaterals. So what are cyclic quadrilaterals? A quadrilateral whose four vertices lie on the circumference of a circle is called a cyclic quadrilateral. The sum of the opposite angles of a cyclic quadrilateral is 180 degrees. So in this picture, A plus C is 180 and B plus D is also 180 degrees. Here's a proof to that. So look at the picture. There are two segments between points P and Q. A is the angle in one segment and B is the angle in the opposite segment. Angles in opposite segments add up to 180 degrees. These angles are supplementary. The proof is A plus B equals half of C plus half of D equals half of C plus D, which is 360 degrees divided by 2 is 180 degrees. Last but not least, alternate segment theorem. Look at the picture. PTQ is the tangent to a circle at T. The segment containing angle TVA is known as the alternate segment of angle PTA because it is on the other side of the chord AT from angle PTA. The angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. So angle PTA is equal to angle TBA. That is the end of the lesson, and thank you for listening.